heard you talk about Ethereum 2.0. So what's the dream of Ethereum 2.0? What's
Hmm.
the status of proof of stake as the mechanism that
Hmm.
Ethereum moves towards? And also, how do you move to a different mechanism of consensus
Sure.
within a cryptocurrency?
So Ethereum 2.0 is a collection of major upgrades that we've wanted to do to Ethereum for quite some time. The two big ones, one is proof of stake, and the other is what we call sharding. Sharding solves another problem with blockchains, which is scalability. And what sharding does is it basically says instead of every participant in the network having to personally download and verify every transaction, every participant in the network only downloads and verifies a small portion of transactions.
Mm.
And then you kind of randomly distribute who gets how much work. And because of how the distribution is random, it still has the property that you need a large portion of the entire network to corrupt what's going on inside of any shard. But the system is still kind of very redundant and very secure.
That's brilliant. How hard is that to implement, and how hard is proof of stake to implement? Like on the technical level,
Yeah,
software level.
proof of stake and sharding are both challenging. I'd say sharding is a bit more challenging. The reason is that proof of stake is kind of just a change to how the consensus layer works. Sharding does both that, but it's also a change to the networking layer. The reason is that sharding is kind of pointless if at the networking layer you still do what you do today, which is you kind of gossip everything, which means that if someone publishes something, every other node in the client hears it like from on the networking layer. And so instead, we have to have kind of subnetworks and the ability to quickly switch between subnetworks and have those subnetworks talk to each other. And this is all doable, but it's a more complex architecture, and it's definitely the sort of thing that has not yet been done in cryptocurrency.
So most of the networking layer in cryptocurrency is you're shouting, you're like broadcasting
Yes.
messages, and this is more like ad hoc networks. Like
Yeah, you're
you're
shouting within smaller groups.
smaller group, but you have like a bunch of subnet, like yeah,
Exactly.
and you have to switch between. Oh man, I'd love to see the.
Hmm.
So it's a beautiful idea.
Hmm.
So from a graph theoretic perspective, but just the software that like
Yes.
who's responsible? Is the Ethereum project, like the people involved, would they be implementing, like what's the actual, this is like legit software engineering. uh who, like, how does that work? How do people collaborate, build that kind of project? Is this like almost like, is there a software engineering lead? Is there,
Hmm.
is it a legit, almost like large scale open source
There
project?
is, yeah. So we have someone named Danny Ryan on our team who's just been brilliant and great all around. And he is a kind of de facto kind of development coordinator, I guess. It's like you have to invent job titles for this stuff, right?
Yes.
The reason is that like we also have this unique kind of organizational structure where the Ethereum Foundation itself kind of does research in-house, but then the actual implementation is done by independent teams that are separate companies, and they're located all around the world in like fun places like Australia. And so you kind of just need a bunch of kind of almost nonstop cat herding to just keep getting these people to kind of talk to each other and kind of implement the spec, make sure that everyone agrees on kind of what's going on and kind of how to interpret different things. Hmm.
So how far into the future are we from these two
Hmm.
mechanisms in Ethereum 2.0? Like what's your sense of the timeline, keeping in mind the previous comment you made about the sort of general
Hmm.
curse of software projects?
So Ethereum 2.0 is split into three phases. So phase zero just creates a proof of stake network, and it's actually separate from kind of the proof of work network at the beginning, just to kind of give it time to grow and improve itself.
Do people get to choose? Sorry to interrupt. Do people get to choose, I guess, which
Yes,
which
they get
consensus?
to choose to move over if they want to. Then phase one adds sharding, but it only adds sharding of kind of data storage and not sharding of computation. And then after that, there is kind of the merger phase, which is where the kind of the accounts, kind of smart contracts, like all of the kind of activity on the existing ETH1 system just kind of gets cut and pasted into ETH2. And then the proof of work chain gets forgotten, and then and things all the things that were living there before just kind of continue living inside of the proof of stake system. So for timelines, phase 0 has been kind of almost fully implemented. And now it's just a matter of a whole bunch of security auditing and testing. My own experience is that right now it feels like we're at about a phase comparable to when we were doing the original Ethereum launch, when we were maybe about 4 months away from launch.
But that's just a hunch. Then
That's
you
just
can't.
that's just a hunch, yeah.
So how, it took like over a decade for people to move from Python 2 to Python 3. How do you see the move from like this phase 0 of for different consensus mechanism? Do you see there being a drastic phase shift in people just kind of jumping to this better mechanism?
So in phase 0, I don't expect too many people to do much, because in phase 0 and phase 1, the new chain kind of deliberately doesn't have too much functionality turned on.
Right.
It's there just like if you want to be a proof of stake validator, you can get things started. If you want to store data for like, other blockchain applications, you can get started. But existing applications will largely keep living on ETH1. And then when the merger happens, then the merger is a operation that happens all at once. I mean, so that's kind of one of the benefits of a consensus system, that like on the one hand you have to coordinate the upgrade, but on the other hand the upgrade can be coordinated.
So what's Casper FFG, by the way?
Casper FFG is the consensus algorithm that we are using for the proof of stake.
Is there something interesting specific about Casper FFG, like some beautiful aspect of it that's
there is.
worth
So
mentioning?
Casper FFG combines together kind of two different schools of consensus algorithm design. So the general two different schools of this design are, right, one is kind of 50% fault tolerant but dependent on network synchrony. So 50% fault tolerant, but it can tolerate up to 50% of faults, but not more. But it depends on an assumption that all of the nodes can talk to each other within some kind of limited period of time. Like if I send a message, you'll receive it within a few seconds. And the second school is 33% fault tolerant but safe under asynchrony, which means that like if we agree on something, then that thing is finalized, and even if the network goes horribly wonky the second after that thing is finalized, there's no way to revert that thing. And
That's fascinating how you would make that happen.
it's definitely quite clever. I'd recommend the Casper FFG paper. If you just search like archive, as in like ARXIV and Casper FFG, it's
That's
right
an
there.
archive. The paper's an archive.
Yeah.
Who are the authors?
Myself and Virgil Griffith.
That's awesome. I'll take a small tangent. This idea of just putting out white papers and putting them on archive and just putting them publicly, is that at the core? Is that a necessary component of cryptocurrency? Is that the tradition started with Satoshi Nakamoto? What do you make of it? Like, what do you make of the future of that kind of sharing of ideas?
I guess so, yeah. And it's definitely something that's kind of mandatory for crypto, because like crypto is all about making systems where you don't have to trust the operators to trust that the thing works. And so if anything behind how a system works is closed sourced, then that kind of kills the point. And so there is the kind of a sense in which the fundamental properties of the category of the thing we're trying to build just kind of forces openness. But also openness just has proven to be a really great way to collaborate. And then there's actually been a lot of kind of innovation and academic collaboration that's just kind of happened ad hoc in the crypto space the last few years. So like, for example, we have this forum called ETH Research. That's like ETHRESEAR and then .ch. And there we publish kind of just ideas in a form that's kind of half formal. Like it's halfway in between, like it's a kind of a text write-up, and you can have math in it, but it's often kind of much shorter than a paper. And it turns out that the great majority of new ideas, like they're just kind of fairly small nuggets that you can explain in like 5 to 10 lines, and they don't really.
They don't need the whole
Yeah,
formality of a paper, right?
exactly. They don't require the kind of like 10 pages of and a filler, and so
Introduction, conclusion is not needed.
yeah, and so instead you just kind of publish the idea, and then people can go comment on it, and
That's brilliant.
yeah, no, this has been great for us.
I think I interrupted you. Was there something else on Casper FFG? That's
No, so just Casper FFG is just kind of combines together these two schools. And so basically it creates this system where if you have more than 50% that are honest, then and you have network synchrony, then the thing kind of goes as a chain. But then if network synchrony fails, then kind of the last few blocks in the chain might kind of get replaced. But anything that was finalized by this kind of more asynchronous process gets can't be reverted. And so you essentially get a kind of best of both worlds between those two models.
Okay, so I know what I'm doing tonight. I'm going to be reading the Casper FFG paper.